So if you go into the course assignment itself, and then that's where you can attach some document that you have already worked on. So why don't you, before I log into mine, why don't you just come up here, log into yours. So like right here, so yeah, I guess you can continue assignment or whatever. And then, so now where, like here it says submit assignment. But is there like an attach something?
Yeah.
Where do you see it?
Down.
Yeah, oh, right there. So then just find your, right there, yeah, and then attach. And then if it's done, then you just submit assignment and it'll come to me.
Oh, wow.
Wait, can I look at it first?
Yeah, you don't have to do it right now, just exit and it's not good. Pretty easy, pretty easy. All right, so let's see. What's on tap today?
I don't have it.
We're gonna process a little field today. And get working on, start working on some lessons. Sorry, I won't keep bringing it back here. It's not you, it's me, I promise.
Put this on video.
I might just sit down for most of my classes today instead of falling down. All right, so we're having a little discussion here today. We have a look at the questions. What did we learn while we're in the field? So I want to process kind of 4 different areas, and then we're really going to delve into lesson planning. So one of your next big projects is you're going to do lesson planning, and then we'll teach it. Talk about characteristics of students and how we need to incorporate that knowledge into lesson planning, and then you all get a chance to teach a lesson out there as well. So at the end, complete your field experience portfolio, analyze and carry out each phase of lesson planning. So I'm going to go through lesson planning, different phases and that. And we're going to practice, hopefully, I'll talk about practice writing some, or at least examining some, because for the most part, textbooks and standards have like objectives written there for you, but we want to kind of analyze them, maybe expand on them, maybe add to them, so on and so forth. And then start you constructing a lesson plan. Now it looks like you have a lot of homework if you do, but it's a lot of it's continuing things. So obviously, first thing, complete your field experience. I want that done. Your portfolio, I want that done by Thursday morning. We're going to look at some of the objectives, but there are lots of pages about objectives in your course packet. I'm not going through them. It'll take us 3 class periods to go through them one by one. It's a reference. I'll pick out some things. I would say for you, go back and like pick out a few more, try to understand how to write objectives. So there's a lot of different pages there. And number 3, you don't have to do anything, you don't have to have anything hard, but consider a lesson that you saw taught in the field. And the only reason that you do that, I have you do that, is just so it gives you like context. So you see how students reacted and how the teacher planned or what they said, so on and so forth. So you don't have to do that, but it just gives you some sort of context. You can choose your own if you wanted to, because that's going to be the content that you're going to create a lesson plan for. And you and your partner from the field will have to get together, because I don't want you using the same one. And then our job, and this isn't due, the plan right now is to have to do next Thursday, but our job is to write a lesson plan, a detailed lesson plan on that particular content, concept there. So, and I'm hoping that you'll do a better job at it than your cooperating teacher did. And not that that means your cooperating teacher did a bad job at it, but it means that you're gonna get a chance to spend a little bit more time. You'll get a chance to, bang ideas around with me and other people. And also, teachers get busy very quickly and they're planning for lots of lessons, and unfortunately their job's not just planning and teaching. There's a lot of other, stuff that goes along with it. Hopefully on Thursday we'll get a chance to spend some time talking about starting to talk about learning theories, depending on what time we get over or what we get over today. So just do like 30 minutes of researching on learning theories. How do adolescents learn mathematics? We'll start talking about that before, which should coincide quite a bit with what you're doing in your ed psych classes as well. And then your special on research paper you should be working on. Hopefully you worked on it quite a bit over the field experience, because the first draft's due next week. So get something written. Now, the better your first draft, the less you have to do with your final draft. So, and your final draft will come at a busy time for you in the semester, obviously that last week. So do a good job on your first draft. And for some of you, you're anal enough when you say your first draft will actually be pretty much done. And I'll just say, oh, you can do a little bit more reading, see if you can add anything to it. Okay, so let's process field experience a little bit. What did you learn about, specifically number one there, what did you learn about preparing to teach? So if you notice, I have it broken down into 4 categories. Preparing to teach, so being prepared to teach. What does it take to prepare to teach? What did you learn about creating a classroom culture for learning? And that's dealing with all the classroom routines, all the classroom behavior issues, all of the interruptions, during the day, and setting a culture setting an environment where you have to build a good rapport with the students so they will react well to you. And the third category is about delivering instruction. Like, what does it take? What did you learn about delivering instruction well, communicating, assessing, questioning students, getting their feedback and changing your instruction throughout the period, whatever. And then finally, like, what you learn about being professional. And along that, obviously, is appropriate interaction with students, but other faculty members, colleagues, administration, parents. Knowing about school rules, policies, things like that. So, I'm a definitely not board today. Anyway, okay, so first one, what did you learn about preparing to teach? What's it take to prepare to teach? Gary starts out.
You need a lot of backups, because there was a lot of times where what she had planned, she got done in 10 minutes. That we was supposed to take up the whole class.
Okay.
She had to one day she just made questions on the fly and had to work on that one and made homework. So I think there's a lot of on that.
Okay. All right. Good. What else? Preparing to teach. What's it take? What kind of stuff did they use to prepare to teach? Brittany, you gonna say something?
I don't know, our teacher, she didn't really seem like she had any thing with her. She had a couple problems, but she would circle numbers of problems she wanted to do, and then when she had them do it, she would just do it with them.
Yeah.
Get the answer, or she didn't really have answer keys for tests.
Yeah.
She would just go through and as they're doing the test, she would do the test and not do the answer key.
Yeah.
And then one time she was just kind of all right, I don't have any students here, so I'm just gonna throw together a review today, and just kind of came up with all these different questions. So she didn't really show us any of lesson plans or what she uses to go off of.
Yeah.
She just seemed she's been doing it for a while, so it seemed like she just likes to go off what she knows.
Right. I mean, I guess anybody else add to that before I say my comments about
She did say
planning.
that she meets up with the other math teachers teaching that to
Yeah.
see what they want to do together.
Right.
That's how our teacher was, during her prep period, she met with the 2 other geometry teachers, and they went through what they had, what they were giving the students for that day, and when they were giving the quiz, and where they were at in their
Right.
chapter or whatever.
Right. I mean, I'd probably say it's unfortunate a lot of times now. I don't necessarily think it's now. I think it's been this way for a long time. That teachers don't spend a lot of time planning a good lesson. They pick out problems they want to go over. And I mean, the unfortunate thing about that and if you know your content, it doesn't really take all that much to say, okay, well, I'm gonna do these problems. I can do those problems. They're easy problems. I've done them maybe for 15 years, whatever, and I've seen these before, and therefore I know how to do them. I think the problem with that is you never end up giving your students a good, clear description or description. I don't want to say lecture. I mean, it can be a lecture. I mean, you should lecture all the time, 5 minutes, 10 minutes, maybe not an hour and a half. But a clearly well thought out series of statements about the concept. You know what I'm saying? And that is something that you really have to plan for. I don't really have to plan. I might not have to plan to do the problem. I'm going to do these 3 problems right here. Yeah, no problem. Early on in your career, yeah, you got to pick apart the problems a little bit better. But later on, and I just think it's unfortunate that people don't seasoned teachers, because I think this would make them better. Seasoned teachers don't really practice how they're going to get their students to understand the concepts. And then also, yeah, they're doing stuff, but they're not like they're not doing anything to make like connections. Hopefully you're learning in your ed psych, and we'll learn in here, that we learn things by making connections with other things, right? And when you just do problems, it's more about the motor skill of, I see this and I'm going to do this and that. It's not about making any kind of mental associations, and we understand those when somebody clearly explains to us those connections. I'm sure when I do a sample lesson plan, that will become a little bit more clear. What else? Anything else on the planning aspect? And I know that you probably didn't learn or didn't see a lot of really good lesson planning, and I mean, like I said, that's a shame. Because math ends up being taught as just a series of problems. We circle these 3 problems, and you have to know how to do these kinds of problems. And like I said, students don't walk out understanding like what the quadratic formula actually is and can do for you. And then they run into a problem that has whatever, cubics, and they look and they say, oh, I'll just use the quadratic formula. I can pretty much guarantee that if given this problem right here, I guess I'll just leave it like that. Many students would try to apply the quadratic formula and not notice it. If I threw that in there, not that they would just overlook the fact that it's cubed instead of square, but just because of the form that it takes, right? The form that it takes, like, oh, just A is 3, B is 4, and C is -3, put it in the quadratic formula. But I have to make some sort of connections between like what it is, and when it's used. But also, just thinking about the quadratic formula. So, all right, even if I get to the point where we say, all right, there's a formula, the opposite of B, plus or minus square root of 16 minus 4 times A times C, all over 2 times A, and I do the arithmetic, whatever. And this, I realize that, and there's nothing wrong with this, I realize that this is the thing that we have to practice the most. It's the thing that we're going to have to take the most time with, because processes aren't necessarily easy. But somewhere in my lesson, I want to push the fact, and I want to push the fact many, many times, is that this quadratic formula is really, really cool, because it gives you a way. I mean, have you ever thought about how cool the quadratic formula is? It gives you a way to solve a quadratic equation by using some combination, addition, subtraction, multiplication, division, and then square roots. Some combination of just the coefficients of the terms. I mean, that's pretty cool if you think about it, right? I mean, that is pretty cool. I can solve this equation with some combination of, it's pretty cool because you can do it with a linear equation, if you've never thought about it. You can do it with a linear equation, you can do it with a quadratic equation, you can do it with a cubic equation, you can do it with a fourth degree equation, but you can't do it with a fifth degree. That's pretty cool, you know, when you think about that. We'll talk a little bit about that in history of math. You know, we'll talk about it in your other classes. But just to formally, you know, make some comments about that, that's the thing that you have to kind of plan for. All right, what'd you learn about creating a classroom culture for learning? What were the cultures like? What'd you learn about building a rapport with your students? Managing behavior, managing tasks. What else goes on in there? Just creating an environment of learning. What did you learn? Anybody have what you thought was a really good environment for learning? They're hard to find. They're difficult to find. You know, shaking your head, but why? What did you see in there that like it wasn't?
I mean, a lot of stuff that like Math 8 classes did was to get ready for the PSSAs.
Right.
And none of the students really had, they blatantly talk about, why do I need to care about the PSSAs? How does this affect me? Like,
Yeah.
I don't see anything from my scores.
Yeah.
And so like with that, they just sit back and like talk or group around. And there's like certain students that were worse than others.
Yeah.
But to deal with them, she just kind of like called them out and then move on, and then call them out again, move on. And it's just kind of like a cycle.
Yeah.
The way she teaches, like, doesn't really let the students, like, go beyond, like, participate as much.
Mm-hmm.
So, like, if she were to, like, as you just said, like, describe what's going on with geometry or something, like, a significant part about it, then, like, the students would pay more attention and would respect math. But, like, she just kind of, like, get some worksheets and figure this out by using this.
Right.
And that lets the kids, like, think math's not
Right.
fun.
Yeah, I mean, I guess two things about that. The PSSA thing, you know, it's unfortunate that it's the teachers, and they're doing it because of administrators, but it's the teachers who push the PSSAs, and the students don't necessarily see a, you know, reason for it. I wish teachers would just stop talking about the PSSAs, and students just took them. You know, I mean, yeah, some students are motivated to say, I just want to do well, you know, on PSSAs. I mean, my son loves the PSSAs, you know, he's only been through third, fourth, and now fifth grade, right? But he's just like, you know, he does well on them. And of course, if you do well, then you don't mind taking them, but most students don't do, you know, a great job on them. So it is more of a struggle. But in general, yeah, you spend all this time talking about them, and they're not used for anything, right? I mean, not at least for the students level. I mean, the students, I don't even understand. One of my son's teacher, or one of my son's friends, said something about, my parents won't even show me how I did on the PSSAs. Like, because they get the score in the summertime or in the fall, whatever. And they won't even show, you know, they won't even talk about how you did. But why not? I mean, that's supposed to be the, you know, cumulative summary of what you learned during whatever, you know, grade it is. So that's just, I think that's a little weird, you know, there. But and then you know, the whole culture of learning. I mean, the culture of classrooms need to be about problem solving. We just happen to solve problems by way of mathematics, right? But my philosophy is every classroom, every course should be about problem solving. You know, it's just that I choose to problem solve through mathematics. A social studies person chooses to problem solve through social studies. You know, English person, but everything should be about solving problems. Like, I don't know why, and I'm not sure which sample lesson I'll do, but one sample lesson I've done in the past is, you know, I come in one day and this is my question for the day, this is my problem. And I have to do this from August 23rd, whenever school starts, okay? This is the culture that I have to try to, you know, get my class to do. I do it with, yeah, and I understand that it's easier to do it with like pre-calculus, algebras, you know, those typical kinds of procedural courses than it is to do with number theory and linear algebra, you know, that some of the upper level classes will take. But I might come in and I might say, what is the distance, and I'm saying it kind of general here just because I haven't thought about this as far as if it was really a problem that I planned for well, it would be about a library is over here, your house is over here, how far is it away, whatever. But the question here is, what is the distance between, now keep in mind, you know nothing about the distance for me right now, okay? So what is the distance between the points, whatever, 3, 2, and 5, 8? Okay, there's my problem. And I would literally just do this. If it's the beginning problem of a unit, whatever, I mean, that's the only question, that's what I'm putting up there. Solve it. How do I solve it? I don't care, solve it. There's no, I'm not giving you any direction on how to solve it. Solve the problem. I mean, that's how life is, right? You know, there's usually no manual for how to solve such and such a problems. You ever see Apollo 13? Apollo, which one is that movie about? Apollo 13? No, you don't know that. Apollo 13, right? I always forget the numbers 11 or 13.
I never saw it.
Oh, but the one where the one where they're having trouble getting people back. Okay, they're supposed to go to the moon, whatever. And bottom line, my favorite part of the movie is that they. Favorite part of the movie is though that there's a filter that they have to replace up there. It basically it's letting poison gas out or something like that. Okay, there's a filter. Well, they're talking on Earth. They're talking about what are they gonna do? These people are gonna die. Okay, and they realize that the filter. I'll probably get it backwards, but the filter's round. All right, the filter's round, but how is that? The filter is round. Something else is square. How is that? Oh, yeah, I don't know. But anyway, it's filter, and so now remember they don't have a Walmart up there, right? And so the engineers have everything in a box that they have up there on their on flight, okay? And they dump it in the middle of this table, and they say, and they pick up like a square thing, and then the size of like a round hole or whatever, and they say, we have to figure out a way, if we're gonna save these people, we have to figure out a way, remember that part? We have to figure out a way to make this fit in this, so it's like a square thing fitting in a round hole, okay? We have to find a way to make this fit into this using only that, okay? And that's all the stuff that they have up there, and so the engineers are trying to figure out how they're gonna design this thing to fit in there to not let the poison gas out, and they eventually do. But the point is that that's a problem, right? And there's no directions for it. So this is it. What's the difference between the points 3, 2, and 5, 8? Again, if I develop this lesson better, it would be there's a library that is at the point here, whatever, and there's your house is at the point here. How many miles is it to whatever? Well, I don't care. Find it. Okay. Now to you and I, we're gonna do this, right? We're gonna say 3, 2, 5, 8, and we're going to use the distance formula because we know it, right? I don't expect any of them to do that though, okay? I expect them to maybe plot it, I don't know. I mean, I would think that the prerequisite knowledge would be that they've had some plotting experience. So if they don't, if I give them, 30 seconds, a minute, whatever, and I'm walking around, then now I'm gonna push them a little bit in the right direction, right? I'm gonna say, well, think about this. We go just plot it, right? We know how to plot points, and those look like points, so just plot it. And draw this line, and then maybe a little bit while later. Well, you have to find the distance right here, right? Okay. And I haven't given them the distance formula yet, because my philosophy is I'm going to help them figure it out and make sense of it rather than just say what most teachers do. There's a distance formula out there that will help you find the distance between 2 points. And here it is. And then now let's practice some examples. I just pull out the examples, all right? But they're not going to have the slightest idea where this distance formula comes from, what it's really used for, any connections with anything. But if I do this, and then they say, well, okay, I've got to find that right there. Well, I don't know, find it. And then, some people are going to get their rulers out, they're gonna try to measure, and they're gonna say, well, okay, this much is 1, right? And then from 1, 1, 1, 1, they'll start approximating it, whatever. And I give them some time to struggle, another minute to struggle. And then I say, well, okay, I see you're struggling, or what I'm hoping is that Colin has done something really cool. And I say, Colin's doing something really good. Colin, go up there and show people what you're doing. And he gives everybody, oh, okay, now I think I can do it here. Now, if not, then I have to say something like, okay, you're struggling with a little bit. What if I said this? If I made you just go perfectly horizontal there and perfectly vertical there, what kind of triangle do I have right? Okay, I got a right triangle. Do you know that point right there? Oh, same over as that point, right? Same up as that point. So I know that. Now, find the distance. See, I'm not telling them how to do it. I'm giving them a little bit here and there, hoping again that somebody in my class, can take the lead after. My point is though that's problem solving, and I don't know that there are very, I don't know that there are. You guys will eventually get one of these, so take one of these. I don't know that there are very many times that you can't do this. So for instance, let's just turn this up here, I don't know. It's fairly familiar to us. How about, I just turned to page 261. So it says factoring using the distributive property. So, and I gotta tell you, if you have a textbook as a good reference, most likely your hard work is done for you. Use the stinking textbook, okay? Don't think that you have to reinvent the wheel. Your textbook probably has a good problem. The problem is some classrooms don't have textbooks anymore because they just go through the standards and they pick out worksheets and it's all about worksheet and there's no real description of it, okay? Let's see, so, I don't know, let me see. I look at the example one, says use the distributive property to factor, 10y squared plus 15y, okay, so we would know how to do that, right? We factor out 5y. Example 2, factoring that, so I'm just kind of studying my stuff here, what I'm going to do. Example 3, okay, you're just going to factor out that 2x cubed. Now example 4 is a word problem. It might look a little unwieldy, but let me see. A deck 3 meters wide is built around a swimming pool with one shown figure below. In order to determine the amount of materials needed to build the deck, our need to calculate the area of the deck. Or the equation represents the area. Well, that's just the area. Square there. I'm trying to think of a problem that I can just start here with. So let's see, the measures of the length and width. All right, what's this? This problem number 45 here. I don't know exactly. I'm trying to look at the first problem there, the connections. The connection on page 261 says to find the width of the rectangle at the right. Divide the area by the length. Well, that's actually probably a good problem. Actually, that's a good problem to start with. Just start with the connection. I mean, I like it because it actually is. If I was training my students to read the textbook and learn from the textbook, but of course I'm the teacher, so I'm supposed to facilitate the learning. But these are good problems, so we should be able to learn while reading, okay? So why not start with that problem? Why, instead of starting with example 1, and I'm just going to factor out a 2, and here's how we factor out the greatest common factor. We look for that 5y, and I don't understand how to find that, whatever. But let's start with that problem, connection. There's a triangle. Write that triangle up on the board. We know the area, right? The area is 3x squared minus 8x. Yeah, I'm on page 261. I went back to 261. So we know the area, and we know the length, x. Question is, what's the width? I mean, that's a good problem. Think about it. I mean, if you, and isn't that the gist of factoring? I mean, do you really understand what you're asking students to do when they factor something? I mean, when you and we don't think like this because this isn't how you've learned. When you take this right here, well, you know, I guess we start with this, right? We say x plus 3 times x plus 4, and we get x squared plus x minus 12, right? We know how to multiply those two, but we get so caught up in the procedures. There. And we say, okay, that's what you get. That we forget what the heck this means that we're actually doing. What this means is we are taking, multiplication is multiplying two things. One of the ways we look at it is an area model, right? So this actually means that we are taking x minus 3 and multiplying by x plus 4 and getting an area. So when we ask students to factor, we're asking them to start with the area and find the length and the width that were used to obtain that area. Okay? So why not let them start with that and say, what's the length and the width? I mean, that's what you're doing in this problem right here. You're saying that you know that the area is 3x squared minus 8x, and the length is x, and what is the width? Well, the question is length times width equals area, so x times what equals 3x squared minus 8x. Just let the kids solve the problem. Just say, there's your area, there's your x, and then say, and then talk to them and say, what you just did was this. You just factored. Now, specifically, you factored, I mean, I guess there's, well, it's just factoring using the distributive property. It's all factoring using the distributive property, I guess. But what do they have to do? They just have to take x and say, if I pull out an x here, what times x, what times x will give me 3x squared? Oh, well, 3x. What times x will give me a negative 8x? Negative 8. So you just did it, 3x minus 8. The point is, though, can I make my classroom a culture of learning there? So, well, what else with that, though, as far as like, how about classroom behavior, routines, and all that stuff? What else would you learn?
Our teacher had like a good relationship with her students, but at the same time, I feel like when she was teaching, she just had them like answer out questions, and a lot of the times the students would talk while she was teaching, and she wouldn't really address it. She would just like keep moving and not acknowledge anyone like talking over her, having side conversations. There were only a few times where she would just be like, shh, like if they started getting too loud. But the students were really distracted. If they weren't paying attention, or really interested in what they were doing, they were doing whatever.
There's a fine line between keeping them interested and active and not goofing off. You don't want them to be just sit there and not active, because then they're, not engaged.
Now, she didn't have any like honors or AP classes or anything, so like it seemed like the majority of the kids like didn't care at all.
Yeah.
So like, how do you engage them if they?
Yeah. Well,
most of them are really just like, I don't know.
Right, and somebody's doing their paper on motivation. You are. Okay. Well, John's going to teach us all about that at the end of the semester. No, but we do know. I'll just write John's paper for him here. No, but we do know several things about motivation, and one of the ways that we motivate students in school at all levels is problem solving, technology, making connections with what they already know. And then I go out there and I don't see that stuff happening. Teachers take pride in the fact that, no, we don't use technology here. I never use, I don't do any of that YouTube videos. But how are you gonna keep students active and motivated when they're just waiting to go home and watch YouTube videos on other stupid stuff? Okay, why not get them to, watch you? They can watch 2 hours of YouTube videos on stupid stuff if they'll watch 15 hours or 15 minutes of video on, something that you're doing in class. Using calculators, apps, whatever. But problem solving, many studies have been done. People like to problem solve. What you don't like to do is sit there and watch somebody else problem solve at the board, and you try to mimic them when you don't see any usefulness to it. that's a challenge. I mean, even though it didn't really come from a word problem, let's say, it's still a challenge. Can you figure that out? Well, it's a puzzle. See if you can figure it out. Yeah, so I mean, it's hard to motivate, but again, it's a culture thing, and you're walking in there in February and March, seeing an entire culture from, August, and so that's difficult. But you have to set that stage in August and September. You're not gonna set it or change it in February. So. All right, go to the delivery instruction. How difficult is it to deliver instruction? Did you get a chance to stand up and talk at all? Was it hard? Tongue get tied? Communication? Yeah, Daddy.
We didn't really stand up in front of the class, but we worked one-on-one with students that, like, if they were absent for a day, she would help us go over the stuff.
Mm-hmm.
And it was really hard when you didn't know what you were talking about.
Yeah.
Like, because they would ask questions like, well, I don't really understand why we do that. And you're just like, well, if you look at the example, then like it shows you kind of the relationship between the process and like the stuff you're given,
Right.
I guess.
Well, I mean, hear what you just said too, is the students want to know like why.
Yeah.
Why does that work? Why does the quadratic formula work? Well, I can show you why it works.
Mm-hmm.
They want to know why. They don't want to just be told what to do. They want to know why. They want to have some reasons for it, and so many teachers don't, provide that for them. Now, obviously, when you're only there in a chopped up time period and not knowing all the stuff, it's harder to answer those questions.
Mm-hmm.
But it is not easy making 3 mathematically coherent sentences come out of your mouth, consecutively,
Mm-hmm.
unless you plan for it, practice it, and know your stuff. And all 3 of those things I think are important, because we know, college professors, right, who are brilliant and know their stuff, but because they didn't plan well, they go in and they ramble, and really no 3 coherent sentences come out of their mouth in a row. Because, like I said, they didn't plan. They just said, I'm going to do these problems, and they didn't really think carefully about how to explain them. And then, what else on the communication level? Like, were your classes, the classes you observed, were they mostly just the teacher communicating? Anybody observe a class where there was really good communication between the students and teachers, like that, or yeah?
There was one class in particular that like the students just wouldn't talk at all. Like, it was a quiet class, and then others were like really more talkative.
Yeah.
So she would, like, if classes had a hard time talking, then she would control the discussion.
And sometimes that's a dynamic just between like students too. There might be some students that don't get along, or some students that are, not nice or whatever like that. What else? Communicating. Brittany?
She just kind of like talked at them, never really involved them. Or
Yeah.
like if she did, she just kind of like, she would give them all these problems and then just say like, let's go over them and say, like, she'd call a person, like, give me the answer. If they had the wrong answer, she'd go to somebody else
Yeah.
and then move on. It was just a lot of that. She didn't really move from like, she had like a little podium that was like on wheels with her iPad.
Right.
She just kind of like stayed behind that, and sometimes she would just sit on the ledge behind that, and that's just where she stayed for like the majority of the class time.
Yeah.
I think she did a lot better with her like her consumer math classes. Like, she would like talk to them, and like, I don't know. When for algebra 1 and 2, it was more just like procedures.
Mm-hmm.
This is how you do this. But consumer math, there was formulas and stuff.
Right.
But like, she started by like talking to them and how they could relate this to like real life. And she like brought her like insurance card out, and was like showing them and like how it all made sense. And then she would go into the formulas, and then kids like were asking questions. But her algebra 1 and 2 class, it was more like, this is just how you do it.
Yeah, and I'd probably say this. I know that some classes lend themselves to more procedural stuff and that, but some of it's because of what we've made them be too. And I will agree with you that algebra classes tend to be more procedural, and that's fine. There's nothing wrong with that. There are a lot of algebraic procedures, However, though, behind all of the algebraic procedures is usually a very, very simple to understand concept. I didn't say anything about simple to do, right? Because sometimes the stuff is hard to do. But just that right there, you know, when you're factoring, all you are doing is trying to find the two parts of the area, length and width, that multiply to give you the area. That's it. Now, when I'm teaching it, I start out with that concept. And while my students are doing the various different, 5 sections worth of procedures that we're trying to get them out, I constantly remind them, this is what you're doing. Trying to find that. Takes me 30 seconds, to talk about that, but I have to, every once in a while interject and remember, this is the concept. Unfortunately, I don't see a lot of that out in school. They're just doing the procedures. And part of it is because the PSSAs are not going to ask you a question about the concept of factoring. That's a shame. They should. They're just going to want to get you, but my point is you don't have to do, you don't have to spend 3 lessons on the concept of factoring. You interject that every once in a while into it. Yes, is it going to take me 10 or 15 minutes to derive the quadratic formula and get my students to try to understand that? Yes. And will they have to do that on the PSSAs? No. But it's also important for them to get a chance to see where it comes from. So communication is a big aspect there. Well, and finally though, what about the professional? What about being a professional teacher? Interactions with people. And you might learn a whole lot there. Just kind of observe. Any comments about that? The profession of teaching. What's that?
I think she was good at having the line between professional and then being personal with them. Because I think a lot of students really liked her, but she wasn't overly nice to them and allow them to kind of be just friends.
Right.
I don't know. I thought she did a good job of that.
And I'm sure some of your teachers can't not talk about the issues in their schools and the difficulties and troubles that they face being a teacher. But I guess my opinion on that is that even though there are a lot of struggles and issues in teaching, there are struggles and issues in every profession. I think it's still a great profession to get into. And that, so don't be discouraged because you saw some things that you didn't necessarily like, because you're gonna see that anywhere. There is no perfect place to work. Work itself, I guess it all depends on what your philosophy is of the world, I guess. But for me at least, man was made to work, but work isn't always going to be enjoyable. It's work, right? It's not always going to be enjoyable. I don't know why people think that it is. And unfortunately, the millennium generation gets knocked because you're trying to find, you want to find purpose in your life, and you want everything to be, nice and fun in your work, and it's like that. For me, it's not gonna happen. That's not where I find. I love my job. I love teaching, but I don't find my life's purpose in teaching. So if you're gonna try to find a job where you find your life's purpose, you're probably gonna look for a long time. You probably will never find it. And if you do, I'd probably say your life's purpose is messed up. But anyway, that's just not. So you can't take it personally. You can't take things that don't go, policies that you don't like from a profession, and think that everything stinks because a school district has a retesting policy that sucks. Anything like that. So. All right, I need to get a drink. Yeah, go ahead.
Well, this is kind of just a general question. Are there teachers that are allowed to say, no, you're not retaking my test? Or do they all
that all depends. In Central Mountain, it's a policy. They've tightened the policy a little bit, and then who knows, the new superintendent will like do some stuff to it that, but yeah. But no, you don't have that option to like just say no. Yeah, I'm gonna get a drink, use the restroom because I've been drinking too much. Say no.
Yeah, the test, well, the grade doesn't matter, you know.
You're already taking your grade's not changing.
Oh, yeah, yeah. Go back over in the smart center and practice.
Oh god, yeah, that was bad. Missed like 5 in a row.
I don't have my course packet.
Yeah, we all get it. Go downstairs, get a snack.
What I was trying to say didn't really come out right.
Like, her not going in depth in her teaching let the kids like not be more focused. And her culture in the classroom was like.
How long was this class?
When I started in
45. And then 11 to 12, 13.
I'm so old.
cool.
Unfortunately, I said you just took your test and passed the papers in history. Today's a lot of me talking day. That'd be good for anybody, especially me. And you don't have to, but if you have your laptop and you want to, I'm going to actually pull up the lesson plan template. Not necessary, you don't have to get it for it if you want to just look at it and see. I'm going to go over like parts of a lesson plan that we want to analyze and add to in our lesson plans when we write them. We went over some of this stuff here. Again, not necessary. I'll show you how to get to the template. But I know Matt put hers up. So, okay, so we're going to go into a time where we're going to plan some lessons to actually teach, and I mean, I like the way we do it because as we're planning, we also will start talking even on Thursday, hopefully, about like how do we plan lessons. I guess go back to my objective. The point is that we want to find out how to construct a math lesson that will maximize the chance of student success. We want to make sure that we are incorporating enough stuff that will maximize student success, which means, and then I want you to make connections here, which means you're taking Ed Psych, and I'll talk to you about things here in this class as well. We need to know how are adolescents motivated. They're motivated much differently than children, toddlers and preschoolers and young, 1st through 5th grade. And they're motivated much differently than college students, as well. You may very well be motivated with, it's time for me to get serious and I gotta get a job because I don't want to live with mom and dad any longer. Can't stand them. No. But now it's time to. So I'm gonna get a job that I'm gonna like and that hurts. No. But then I'm gonna like, and it's gonna allow me to provide family and something that I do enjoy doing. But that's not very motivational to 7th and 8th graders. I mean, we try to pretend like they have to think about a job later. Consumer math. Who wasn't said something about consumer math? That's a difficult class. We actually we're going to try to bring it back. We have a consumer math class on the books here. Like, that's stuff that you need to know. Like when you're student teachers, I do a couple little lessons on teacher finance and stuff like that. We talk about retirements and we talk about healthcare and salaries and stuff like that. But that doesn't make any sense to the 10th grader taking consumer math, right? Investments. I mean money. What investments mean? Your house. We're or shopping for a house, and you gotta get all these inspections. That is so far, in the future,
She doesn't like it.
who cares? Who cares about that stuff, right? But for you guys, you think about that, that might be interesting to kind of know. But the point is, that, so we need to know, like, how do students learn? How do kids learn differently than, adolescents, and adolescents learn differently than adults. So how does all that stuff happen? So we want to try to maximize student success here. So when you think of a lesson plan, I'm not sure why that is there, but just have some delay here. I'll just bring it all up here. When we have a lesson plan, and I kind of just went through my template that I'll show you here in a few minutes, but it's really just a template to fill in, and I do this for uniformity purposes. It's not like you have to write all of these in order to be a good teacher 10 years down the road, but these are things that we need to think about as we are teaching. So, you got to know the topic and the grade level. Okay, this is for 8th grade. The topic is ratios and proportions. You don't need a title. It doesn't need a title, but just what is the topic and overall grade level. Lesson goal. A goal can be written in really broad terms. Like, I want my students to understand something. Understand's broad. I want them to know something. That's broad. It's a goal. When you get down to your objectives, this is where we want to focus on. This is a specific description of what the students are going to be able to do at the end of the lesson. All right, students will be able to try to stay away from words like understand, know, and practice. Now, understand and know, yeah, you can put that once in a while. If that's the focus of it, then I see, well, you're not clear on what your students should be able to do at the end. If practice and review, those aren't learning objectives. Those are activities. They're going to review something. We're just going to practice it. Nothing wrong with those. I'm not saying there's anything wrong with those at all. But they're not objectives. They're going to practice. So we've got books. Let's just look at, you're probably all at 261 still. So let's look at that objective for that lesson. And again, don't reinvent the wheel. If they're in your book, get them. If they're in curriculum guide that you're using, get them. But you also then have to look at this. So let's look at this description or this objective first. So you should be able to use the greatest common factor and the distributive property to factor polynomials. That's pretty darn descriptive, right? So we've got a polynomial, and I just want them to use the greatest common factor and the distributive property. So you pull out, and really it's the distributive property backwards, right, when you factor, but you're thinking about the distributive property, of course. But this is just using the GCF. Now when you read that right there, so if you put that on a lesson plan, and this may be more for me than you, but if I read this on your lesson plan, I would look at that and I'd say, well, I know what you're not doing. You're not taking a polynomial and splitting it up into binomials. So FOIL backwards, I hate that word, right? But FOIL backwards. This is just about, you got a polynomial, you're pulling out an x, pulling out a 2x squared, something like that. That's what that tells me. Now what I want to do also though is this, I want to go back, I want to go now to the homework problems. And there's only one objective here, right? Now, I would say this, if it's a 50-minute class, and this is what I like to get out of the habit of, it's a 50-minute class, or however long it is, that lesson right there, I know it's one lesson. I know it's one, or I don't want to say it's a lesson. I know it's a section, okay? I have no idea what idiot invented one section per day in the math vocabulary, okay? I can only get over one section a day. Why? Because it's one section. And one section is one day. Math people were way too liberal, when it comes to that stuff, right? One section a day. When my school was trying to go to, one of the schools I was at, first school, we were trying to go from regular scheduling to block scheduling, and so it was like, it was going to be 90 minutes, and we were only going to meet for half the year, and then change class or whatever. You know, one of our brilliant math people was like, well, I've done the math, and if you take all the sections in the book that I've got to get over and divide by the number of days, then I'm not going to get over. And I'm like, teach 2 or 3 sections a day, you idiot. I mean, this isn't rocket science. Who said we had to teach 1 lesson a day? And even if it's only a 43-minute class, it's going to take me 43 minutes to get my students to use the GCF and the distributed property of factor polynomials. They better not. You know, so I might look at the next section, factor by grouping or whatever, and I said, maybe I should just teach 1 lesson on factoring. Now, is it possible that that might still take me 3 days because I'm going to teach a lesson on factoring, then we're going to practice them? Yeah, but why on earth would this mean it's only going to take me 2 minutes to talk about the concept? And do I really need to spend then 41 minutes? And I know there are other administrative things you have to do, right? But is that really going to mean that it's going to take me the other 39 minutes or whatever I said to do a bunch of practice problems? You know, no. Chances are if you did that, you're going to have 15 minutes at the end of the day, or at the end of the period, where your students are going to, you know, you're going to tell them to do their homework, right? And they're going to fool around, and then you're going to complain the next day, or the next month, you're going to complain that I still don't have enough time to do. Well, it's because you're not planning well enough to get over, you know, all the stuff. And that's about expectations too. You know, I expect my students to do some stuff at home, and you know, and stuff like that. Well, anyway, what you want to do though too is this. I want to go over to the homework problems because I'm going to assign some homework problems, right? And I need to make sure that the homework problems, to see if there are any other objectives that were missed there. So this is just use the GCF and distributed property of factor polynomial. Okay. So I go to page 263, and this is the exercises, practice. So that's, you know, that I'm just factoring out GCF, factor each, and this is only GCF, which I think is personally a piss poor way of teaching people to do this stuff because you know, you get a problem that looks like 31. Look at 31, and I realized actually maybe 31 is fine. Now I know that 31 is only going to be factored by GCF. Okay, I factored out what a 2 and an M and an N. Is that right? 2 M. Now answer this question for me. How did I know that that problem was only going to be factored out, or was going to be factored only by GCF and not by binomials? How did I know that? Don't miss the obvious. How do I know? Because I'm super, super smart. Right. Because it's in the section called factoring using distributed property, and that's the only objective, right? You missed the obvious. Now, what does that do for the kid when on the test, right? There's a problem like that, and it can't be factored by, it can be factored by, or it's only factored by GCF. So what I mean is, so what about my problem like this? So, because now remember, later on I'm going to do problems where, you know, yeah, there'll be x squared minus 5x plus 6. That one, that's one that can be factored into, you know, x minus 3 and x minus 2, right? All right, now, what if I do this though? What if I change that to, well, I'll say x squared minus 5, so I want it to look really good. That right there can't be factored, right? That right there can't be factored. Your factors are, oh no, that's not true, it's -6, so let me just change that to 4. Okay. That can't be factored. However though, what if I put just a 2 out there? And I give, now this is my 26 years of experience, okay? And then I give that. Guarantee 90% of my students are gonna miss it. You might miss it. Because you're gonna sit there all day long, and I'm kind of hoping that it doesn't, right? You're gonna sit there all day long and try to do this. You might find it, is there any? So it's gotta be a minus and a plus, right? So 5 and 6 and 1. So -6, and 2, shoot. So I need to change something to an 8. Change that to an 8. Will that give me anything? So 2, 4, 2. I'm hoping it doesn't factor. -4x on 4, no. 8 and 2, that's not gonna do it, right? 8 and 2, 16, that's too much there. Or 8 and 1, sorry. 8 and 1, that's too much. 4, anybody see anything in a factor? 4 and 2, I already said that, right? 4 and 2, -2, and 8, that's 6. So, okay, and then not factorable, right? Not factorable, it's prime. No. No, I factor out 2, right? But you see the problem there? So that's kind of my problem with section by section with like factoring stuff. Because you might say, you might have answered that question with 31 by saying, well, because it doesn't look like any x squared minus 4x plus 6 kind of thing. It's got the m's and the n's, but you don't know that. It's just about factoring. Well, anyway, but now look at 36 and 37 here. So this is connection geometry. Write an equation that represents the measure of the area of the shaded region in factored form. So clearly they want us to factor it at the end. But that tells me this. I'm not going to solve that because I'm not sure. Let's see. Write an equation represents the measure of the area of the shaded region. So, you know what? A plus 2 and 2, right? So A plus 4, and then B plus 4. And then that's the whole thing. So then I'd have to subtract AB. Is that right? Follow me on that? So the whole thing. So I'd have to get an expression. I'd have to actually take, what would I have to do? I'd have to take A plus 2, multiply it out B plus 2, or B 4, sorry. A plus 4 and B plus 4. Multiply that out. Subtract AB. All right? I'm thinking about that clearly. Subtract AB, and then get this thing. But then it says in factored form. Okay, now here's what I'm thinking. If you're going to have your students do that problem, you better add an objective. See what I'm saying? Don't give them that problem if that is the objective. And don't give them that problem if you only give this objective here and then you don't do any problems like that. So what would my objective be that would get them to do that? Because that's more than using the GCF and the distributed property two-factor polynomials. What would another objective be in there? What do I want them to do? It's a higher level objective, right? Because it's not just a memorizing a procedure and that. What are some higher level words that I could use instead of just factor? What are you doing there? Gotta start thinking critically about what we're going to ask our students to do. I'm thinking applying, right? When you apply something, that's a higher level than just mimicking something and doing something and memorizing a procedure. Because there was no procedure for that, was there? I actually had to problem solve. That'd be a really good problem to have my students just start problem solving, right? So I need to, maybe I'll rewrite another objective that says something like, let's apply previously learned procedures, knowledge on area to rewrite in factor form, something like that. But they're applying it, so it's definitely a higher level there. So I have to see what, if I want to write good objectives, I have to see what they are actually going, what am I going to expect them to do. Same thing, I guess, on the next page, some applications. Applications obviously are applying. What's this gardening? The length of Jeremy's garden is 5 feet more than twice its width W. Typical problems, right? This year, Jeremy decided to make the garden 4 feet longer and double its width. How much additional area did Jeremy add to his garden? Well, it's the same thing, right? It's just a, so now though, the difference there would be, this is just applying it to already. This I actually have to model. So now I'm going to use even a better, maybe a higher word. I have to actually model a situation with math, and then apply GCF to a modeling situation. You have to work on my objectives there. But you see how that's different, because when we say model something, we mean take word problems and make some math out of it. This is not modeling. 36 is not modeling. 36 is just somebody gave you a diagram and you have to figure out the area. When I'm presented with words and I have to come up with that, the math that goes with it, that's what we call mathematical modeling. That's hard. You know. And then actually, I mean, the question just says how much additional area. It doesn't say anything about adding it, you know, or writing it in a special form. Well, anyway, so we got to think about objectives. What are specific things that they're going to do? And then you always want to see where they fit in the standard. Sometimes that's already done for you. What material you need, what do you need, what do the students need? Just get yourself organized. And then, what are some other things here? Assessment. Think about how you're going to assess your students. You're going to give them homework probably. Hopefully, you're going to do something, what we call formative assessment, which is while you're teaching, to help form your instruction. So formative, the root word is form. Hopefully you're going to use some formative assessment and ask questions. Maybe you'll have them do problems in class. That's assessment, and you're going to do what? Roam around the room and see how they're doing. You got to make sure they match the objectives. So this is why it's important for me to say this. Well, and this is where I would go back to my homework. So I wrote the objective, and I saw that I only wrote that one objective on GCF. And then I looked and I said, okay, what homework problems are we going to assign to them? We're going to assign 46. Well, wait a second. I better do that homework problem because that 46 is not that objective, does not meet that objective. So I better do some problems where I can say, hey, let's see if we can pick that apart. And that, to me, is a really good place to start your entire lesson on GCF. So maybe I'll teach a lesson. And then now you start thinking about your procedures. Like now, how are you going to get your students to meet your objectives? This is the main part of the lesson. You usually have an introduction, a body, and a closure. So I've said before, you got to tell them what you're going to tell them, and then tell them, and then tell them what you told them. Right? So you got to get students motivated. Again, maybe a word problem. It's not very motivating for me to put 3xy minus 21y plus 5x minus 35 up on the board and say, today I'm going to teach you how to factor out a common factor. Or what does it have in common? That's not very motivating. Get them motivated, have students do something. And then at the end, you summarize what was done and learn. So you tell them what you're going to tell them, and tell them what you told them. You know, I like to teach through overriding problems, like what's the problem of the day, what's the question, something like that. Students should be actively engaged doing something, okay, whether it be physically or mentally. I mean, from an adult standpoint, you can mentally engage them more than you can kids. They need to be more physically engaged. And when you think about a lesson plan, a lesson plan is a description of what you're going to do. So for math, when you write your lesson plans up, describe what you're going to do in words, because obviously if you're doing it in a word processing, like even if it's Word, that takes a long time to like write up all your examples and graphs and stuff. Forget that. Those are your notes. You teach off your notes probably. You plan your lesson through a lesson plan. And the lesson plan is a description. You read that lesson plan before I'm going to teach. Okay, what is it that I really want to do? Then I have my notes. And my notes have the problems and the examples and all that stuff. You don't have to write all those up. So you do that in your notes, not the actual lesson plan itself. And then we don't do a lot in here with adaptations. You learn a lot about that in your special ed classes. However, though, these are any adaptations made based on IEPs. But probably more importantly for us is these are still considered adaptations. What are you doing to meet the needs of all students? And we do this more in methods too, so I don't worry about it a whole lot here. But what kinds of things are you doing that will meet the needs of all students? Sometimes you end up finding that the thing that you're doing up here specifically to meet somebody with an IEP is something that ends up being really good for all students. So just use them. We call it universal design for learning. We talk more about that in methods too. But that's kind of a mindset that we'll talk about a little bit later. And then I always have students do a pre-reflection. So you do reflect after you teach, but you pre-reflect by, that's just a made up word, not made up. Because you reflect before you actually teach it. You reflect on what possibly could go wrong, okay? Things like that. So the first part of a pre-reflection is, what are some possible problem areas for students? Like, where could they possibly have some issues? Well, they might not have a good background in this, so that might cause them some problems. There's a little caveat to this problem that they might get stuck on. What are you gonna do about it? And then reflect on, like, what's your discourse look like? How are they interacting with the math? How are they interacting with each other? How are they interacting with me? Or is it all me just teaching them and going over problems and then them doing some things? So what does the discourse look like? What's your assessment look like? How are you figuring out whether they can do anything? And then what homework are you giving? And when you assign homework problems, you got to do it. Think ahead of time for good problems. Don't just assign all of the odds. I'm going to look through there and I want to say, hey, that's a pretty good problem. I like that number 45 or 46, whatever it was. And then, I would say with homework assignment, fewer problems are better than a lot of repetitious ones. Few problems with getting the nuances. I'd rather than practice a few repetitious problems in class, because then I can monitor what they're doing, and I don't want them practicing the wrong thing. The person who invented the phrase "practice makes perfect" was an idiot. Because practice doesn't make perfect. A perfect practice makes perfect. If you're practicing the wrong thing over and over and over, right? And that's what you can't monitor at home. If you give them 20 problems to do of the same thing, and they do the same thing wrong with all 20 problems, all you've done is reinforce the bad, incorrect behavior. Do a couple, come in and let's talk about it, and then, maybe tomorrow, go home and do 15 more practice. Or maybe practice 3 or 4, in here. So that's always better. And then reflection at the end. What went well, what went poorly, what do you need to rethink? Were you clear with your directions? A lot of times I walk out and I'm like, I don't think I was clear. What I really wanted them to do. And then think, were they actively engaged? Did they do something? Did they seem interested in it? Did they ask questions? I mean, when a student asks a question about something, why did this work? That's good. It tells me they're thinking. And if I just say, well, I don't really know, so just move on. Are you prepared to answer the question something like this? So you're teaching a middle school classroom and you're teaching this, and you've got your whole lesson plan, ready to go, and you want them to invert and multiply, right? Maybe simplify this a little bit here. Like that. And Johnny on the spot in the back says, well, I mean, I just did 12 divided by 3 and got 4, and 4 divided by 7 and got 7. Why can't I just do that? I mean, why can't I just do that? Are you prepared to answer that question? I'm not going to address that here, but you can always do that. Okay? It just doesn't always work out well because I've got a special problem. So are you prepared to answer that kind of questions? Well, when you start thinking about it, well, you know what? When you go to live text documents, because I don't know if I put this on your homework side or not, but you should probably go in and look at. So if you create a new Volcano University lesson plans, there is a secondary math lesson plan. Okay, and I'm going to create another one. We'll jump in the box. So when you create that, you will see the different pages And what I've done here is this, when you create these, then you just go into the editor, so if you need to create a lesson plan, you start with a template, you just edit, and obviously get rid of my directions, okay? You write your, I say answer the questions, but these are just prompts, you don't have to answer everything in there, but just get rid of that, otherwise your lesson plan's gonna look really long. You know, but what does it say there? I've given you a description for each of the categories. So we start out and just some introductory information. What's the content area and grade level? You know, just tell me, this is 7th grade. It is pre-algebra, and the content is factoring, well, pre-algebra. What do we need in 7th grade? You know, maybe a ratio, proportion kind of thing. And then the overall goal, you know, what is it? I want my students to do what? Okay. Then you get into more specific information. Again, it just tells you exactly what to do in the directions. But again, they're prompts, you don't have to answer all the questions. So you have learning, and then specific information, you have learning objectives and instructional objectives. The learning objectives are what your students are going to be able to do at the end of the lesson. The instructional objectives are what you're going to do. Like, I'm going to derive the quadratic formula. I'm not expecting my students to derive the quadratic formula today. So I wouldn't say that a learning objective is, my students should be able to derive the quadratic formula. Now for you guys, I might have an objective, you know, later on in the class that says I want you to be able to derive the quadratic formula. But I wouldn't expect my Algebra 1 students to derive the quadratic formula. But an instructional objective, that's what I'm going to do. I'm going to derive it. I'm going to provide them with some problems due in class, you know, whatever. But what are specific things they're going to do? Any essential questions, and you don't always answer all of these things, but you know, are there any essential questions you can think of? Standards, materials, and we don't do all these here, like standards, we're not going to connect them to standards until later. And then you get into your assessments. How are you going to assess? What homework are you going to assign? You know, and I purposely put assessments up here and not at the bottom, like as the end assessment. You think of assessment being at the end. I purposely put it up there because you need to think about how you're going to assess whether the students meet the objective before you actually teach. And especially if you're going to assign homework, do all the assigned homework problems before you plan the lesson, because that's going to help form your instruction. And then you get down to the lesson body. How are you going to introduce the lesson? What procedures you're going to use? How are you going to close the lesson? And then there's your reflections on the different areas. Okay, so again, homework, field experience. And we didn't, I need to go through those, so actually you don't have to do number 2, because we need to look at those more carefully. And then just start thinking, what lesson am I going to teach better than my co-op did? You might want to do something completely different. Spend 30 minutes thinking about learning theories, work on your social projects. And then, you know, I think walk away from here. I know some of you dealt with some frustration out in the field, but you know, I still think that teaching, it's a good profession to get into. You're always going to have frustrations. Every school is going to have their issues. You're always going to have bad students. Good thing is there's always May and June and it ends, and then you get a new crop next year. You get, you know, that's the good thing, right? You know, when people have jobs, they only get 2 weeks out of the year vacation, and it's just, you know, kind of the same things over and over. You never see a light at the end of a tunnel. I mean, you might have projects that are, you know, completed and things like that, but you never see things be, you know, like start over again. And then we're working on this, you know, writing clear objectives. That is really the key to a successful lesson. We got to figure out where we're going with it, what our students need to be able to do. And we just got to practice this stuff. You know, writing a lesson plan is not automatic. It's frustrating. It's going to take you hours at first, and then you can write them quicker, and then you get, you know, better at it. But think about it like creating a painting. You know, the lesson should be a work of art. You know, you should go in there and say, okay, how am I going to do this? You know, put all this stuff together. Make it make sense to the students. All right.
Are we taking these?
No, you don't need them. I'll bring it back. Cold here or chilly?
It's freezing.
Yesterday I was sitting beside my computer in my office all day long and I was still freezing. Hate being sick. Problem was I worked security on